In this video, I'm going to give you a summary of trigonometric integration. So when it comes to trigonometric integration, always have these three in the back of your mind. So when it comes to integrating cos squared, then use this. Put this into here, and then this will then give you this. Now, cos 2x is really easy to integrate. So you can always easily integrate cos 2x. So when it comes to this, replace it with this. Then this thing here is really easy to integrate, and the same goes with sine squared. Put this into here, and then cos 2x is always easy to integrate. So remember, you can always easily integrate cos squared and sine squared. So for this one, so when it comes to cos to the power 3 and sine to the power 3, break this up as one block multiplying another block. So now change this so that it's written all in terms of sine. So for example, if you look at this here, rearrange this. So cos squared equals 1 minus sine squared of x. You can put this into here. That will then give you this. Now once it's in this form, it's really easy, because if you look at this is the exact derivative of sine of x, or almost the exact derivative, because if you look at this as, if you view this as one block multiplying another block. Now if I were to give you something like sine x to the power of, let's say, 5, when you come to differentiate this, it will be 5 sine to the power 4x, and then you've got to times the derivative of this bubble. So the derivative of that will be cos of x. So now you can see that this thing here matches up with this. So when everything is written in terms of sine, if this block is all written in terms of sine, then it should be easy to integrate this, because you've got something that's the exact derivative of sine of x. So when you get to this stage here, realize that this is the exact derivative of sine of x. So when you get to this stage here, when you get to this stage here, realize that this is the exact derivative of sine of x. So you can make the substitution. Let u equals sine of x. So du equals this, and then rearrange it to get dx under sine. So when you put this back into the dx here, you can see that this will cancel out with this. So this whole thing here will then become this, and then it's really easy to integrate. So always keep an eye out for if you can get this block, no matter how complicated it is. If this block here is the exact derivative of sine of x, then you can make this substitution, and then it will become really easy to integrate. So the same goes with sine to the power 3. So hang on. So sine to the power 3. So sine to the power 3. Break it up as sine squared and sine, and then rewrite this block all in terms of cos. So make use of this. So rearrange this. So that will be let me think. Sine squared x equals 1 minus cos squared whatever. So you put this into here. So that will then become this. And then now you can see that this is near enough the exact derivative of this. So this block here is all written in terms of cos, and then sine is the derivative of cos. So you, when you get to this stage here, because this is the exact derivative of this thing here, then you know that it should be easy to integrate. So make this substitution. And then blah blah, that will then take you to here, and then this would be easy to integrate. Okay, and when it comes to cos to the power of something that's really high, or sine to the power of something that's really high, then make use of the reduction formula. Make use of the reduction formula. Okay, and then bear with me. So when you have something like this, one block multiplying another block, use this one here to break it up as this, and then if you can rewrite this all in terms of sine, then this is the exact derivative of everything in terms of sine. So the trick here is to from here obtain your cos and then rewrite this block in terms of sine. So you want everything in here to be in terms of sine. So make use of this. So so if you put this into the middle block here, then now you can see that this block is all in terms of sine, and then you've got cos. So you know it's easy to integrate. So so this thing here will then become this, and then you can make this substitution, and then you can see that this is really easy to integrate. Okay, so when you get something weird like this, let me think. So you've got one block here and one block here. Break this up as one block multiplying with another block, and then now you can see that everything is in terms of sine. Everything is in terms of sine. Then now you can use you can make use of, well, when you get to this stage here, then integrate everything separately. So integrate this, and then integrate this. So now you can make use of the reduction formula. So in the process of working this out, you will automatically work out sine to the power of 8 and sine. You see what I mean when you try and integrate, when you try and evaluate this. If you try and integrate this, in the process of you integrating this, you will automatically solve this if you use the reduction formula. You see what I mean if you try and do it for yourself. Okay?